Pixi.js is one among many other libraries that help web developers to achieve an amazing user experience for websites and web applications by providing the necessary tools to create an eye-catching interactive content. It also makes the development of 2D games for web browsers and mobile so easy even for developers who have literally zero experience in the field of game development. What sets Pixi.js apart from the other libraries though is how performant it is thanks to its reliance on the GPU to render elements rather than the CPU. In addition to that, the richness of the library, despite being so easy to work with even for complete beginners as long as they know the basics of JavaScript. So without any further ado, let's get started. Let's start off by creating a folder and run the npm init command to generate a package JSON file and then create the index page. Now, one way to get Pixi.js is to install it through npm, so let's do that by typing npm install Pixi.js. Once installed, we need to link to the library's file in the HTML code. Then let's create a JS file in which we are going to type all of this tutorial code. That done, to start using Pixi, we need to create an instance of the Pixi application class. Now, if we take a look at the console, you see that message which indicates the versions of WebGL in Pixi that we are currently running, which in itself is an indicator that we have everything set up correctly. The next step we need to do after we created our Pixi app is to append it to the DOM. This black square on the page is the container of the interactive content, whether it's a carousel, a 2D game, or whatever we are trying to achieve. So, as you see, we created an instance without specifying any options to the constructor, but we can actually do that by passing a configuration object, and some of the properties we can set are the width and height of the canvas. We can also set the transparency value to true, which will get rid of the solid background color. There is also the anti-alias property, which basically smooths and fixes the pixelated edges of images and shapes if it is set to true. That said, we are able to change the options after the initial call of the constructor. We can, for example, change the background color of the canvas, typing the following line of code. Resizing the canvas is also possible using the resize method. So here we are setting the width and height to match the size of the browser window, but notice that we have an additional horizontal and vertical scrollable space because of the default styling set by Chrome. To get rid of that space, we need to change the style of the canvas element and set its position to absolute, and then we need to remove any default margins and paddings. Here is an analogy to wrap up what we've done so far. You can think of the application instance as a new Photoshop project. The app.renderer is an internal mechanic that is responsible for drawing elements on the canvas, while the app.view is the canvas itself. With that said, let's create a shape and we'll get back to the Photoshop analogy in a second. Shapes in Pixi.js are stored in the graphics class, and every shape we are going to create is going to be an instance of it, whether it's a circle, a rectangle, a line, etc. Now, to transform the graphic we've just created into a rectangle, we need to follow a couple of steps. The first step is to call the beginFill method and set a color for the rectangle. The second thing we need to do is to tell the renderer that we want this graphic instance to be a rectangle by calling the drawRect method, which accepts 4 arguments. The first 2 arguments represent the coordinates of the rectangle on the canvas. I'll get back to this in a moment. The third and fourth arguments represent the width and height of the rectangle respectively. The third step we need to do is to call the endFill method. That done, now we have a rectangle that is ready to be drawn on the canvas, but before we do that, bear in mind that these methods are chainable. Therefore, we can make this code concise by calling these methods from the same variable. Now, to display the rectangle on the canvas, we need to call the addChild method from the stage member of the app and set the rectangle as an argument. We can add stroke to the rectangle by calling the lineStyle method, and here we can set the width of the stroke, the color, and the alpha or the opacity, which needs to be a number between 0 and 1. So, back to the analogy, shapes and images in Pixi.js are pretty much the same as layers in Photoshop. When a layer is prepared, we can add it to the box using the addChild method, and stage here is basically the layers box, and then once a layer is added to the stage, it will be rendered on the canvas. Now let's talk about the coordinates that we used in the drawRect method. The canvas has two lines which represent the horizontal and vertical space. They both start from 0, and the 0 of each line starts at the top left corner of the canvas. Based on that, each point on the canvas is represented by a value from the x-axis and another one from the y-axis. That said, the 00 point represents the top left corner of the canvas, while the 200 point represents the first point of this rectangle. This time, let's create a polygon. Again, we need to use the begin fill and set the color of the polygon. Then we need to transform this graphic instance into a polygon using the drawPolygon method, which takes an array of numbers as an argument. Each pair of numbers represents the x and y coordinates of each point of the shape. The rest is pretty much the same as we did with the rectangle. We can also set a stroke to the polygon using the lineStyle method. Another example of shapes that we can draw is circle. So let's create another instance of the graphic class and call the beginFill method. Now to transform this graphic into a circle, we need to call the drawCircle method, which takes 3 arguments. The first couple of arguments represent the x and y coordinates of the center of the circle, while the third one represents the radius. Notice here that the circle is above the polygon, which is due to the order in which we added the shapes to the stage. So to change the order, we just need to add the shape we want to be on the top to the stage after the one that we want to be at the bottom. Lines are also one of the shapes that we can draw by creating an instance of the graphic class. Here though, we can't fill a line with a color, so we don't need to use the beginFill method, but we have to use the lineStyle method instead. Then we need to specify the coordinates of the first point using the move2 method, and line2 to specify the coordinates of the second end of the line. There are a few other methods to draw other types of shapes like ellipses or rounded rectangles. Not only that, but we can add another set of complex shapes by installing the Graphics Extras module. To do that, open the command line and type the following command: npm install @pixi/graphics-extras. Then of course we need to link to it in the HTML code. Torus is a complex shape which is basically a circle with an outline that forms a sort of a donut-like shape that can be used to create a loader, for example. To draw one, we need to create another instance of the graphic class and call the beginFill on it. And then we need to call the drawTorus method, which takes a set of arguments. The first couple of arguments are the coordinates of the center of the torus. The other two are the radiuses of the inner and outer circles. We can add another couple of arguments which represent the location of the start and the end of the arc to draw. Let's finish this section with the last example, which is the star shape. So after creating the graphic instance and calling the begin fill on it, we need to call the drawStar method. The first two arguments of the method represent the coordinates of the star, the third one represents the number of points, and the fourth argument represents the radius of the star. Text is another type of object that we can add to the canvas. To do that, we need to create an instance of the Pixi text class and set the string we want to display as an argument to the constructor method. Then we need to add the text to the stage using the addChild method. Now that we created the text, let's add some style. To do that, we need to create an instance of the textStyle class, which takes an object as an argument. So to change the font, we need to use the font family property. To change the size of the text, we need to use the font size property. Fill represents the color of the text, and we can use the same values as we do in CSS here. It could be a named color or the hexadecimal representation of a color. There are a variety of other properties we can add, like stroke, shadow, etc. Now we need to pass this style variable as a second argument to the constructor of text. The text can be changed later. To do that, we need to update the value of the text property that belongs to the text instance. The same thing goes for the style. We can change any property using the dot notation on the variable holding the text. So here, for example, we can set a few properties to add a line break and center the text. Now, if we want to add elements to the canvas automatically, what do you think we should do? Your answer is probably going to be, let's use the setInterval method and place the code we used earlier to create elements and the callback function of the method. Well, this answer is correct. However, it is not the best solution. Actually, it is so bad in terms of performance. A better answer if you have done a lot of animation using JavaScript will be the usage of the requestAnimationFrame method, which is a really good solution. But still, Pixi.js offers an even better solution, which is built on top of the requestAnimationFrame method. So to create, add and animate elements on the canvas automatically, we need to call the ticker method, which takes a function as an argument, which in its turn calls another function that we are going to create next. Loop here is an arbitrary name for the function that will be called by the ticker method, and as you may have guessed, this function is going to hold the logic we want to be executed each time it gets called by the ticker. So essentially, this snippet of code will add a square to the canvas in each frame. Having said that, the number of frames per second depends on the user's monitor, so on a 60 Hz monitor, the loop function will be called 60 times per second. That said, there is a room for some lag, and the duration of that lag is stored in the delta parameter. App screen width and app screen height return the width and height of the canvas respectively, and the result of multiplying them with the value returned by the math random method will return random values set as coordinates for the rectangles to be drawn on the stage. That done, let's take a look at the result. We define an image as a texture in Pixi.js. Furthermore, we can't add a texture directly to the canvas. Instead, we need to put it inside of a sort of a container before appending it to the stage. That said, let's add an image to our canvas, and as you see, I have already added a folder with a few photos to the project folder. So the first step we need to do is to create a texture out of an image using the Pixi texture from method and specify the path of the image as an argument. The second step is to create an instance of the Pixi Sprite class and set the texture we've just created as an argument. And the third and final step is to add the sprite to the stage. Let's take a look. And there we go. We can actually create a texture and a sprite at the same time with one single line by using the Pixi Sprite from method. Now that we learned how to add elements to the canvas, it's time to learn how to change their coordinates, rotate and scale them, and create animation using these geometric transformations. The first thing we are going to do is to change the width and height of a sprite using the width and height properties. We can do the same thing using the scale x and scale y properties, but in this case we need to use relative values instead of absolute ones. So scale x 1.5 here increases the width of the image by 1.5 times its original width. Scale y2 doubles the height of the image. We can change both of the x and y scale values using the scale set method. Now to change the position of the sprite, we need to update the values of the x and y properties. To create an animation from the position change, we need to use the ticker method, so here we can make a horizontal translation animation by increasing the value of x by 1 pixel per frame. And similar to scale.set, we can change the x and y values with one instruction using the position.set method. Another geometric transformation we can do is rotation, and the unity here is radian. Notice here though that the origin of the rotation is the top left corner, not the center of the image. To see that clearly, let's animate the image by increasing the rotation using the ticker method like we just did with the X translation. As you can see, same as CSS, the default origin of the rotation of an element is its top left corner. To change that in CSS, we usually update the value of the transform origin to center, and the same property exists in Pixi.js but under the name of anchor. So, to reposition the anchor to the center of the image, we need to set its x and y values to 0.5. And then again, we can change the position of the anchor with one instruction by calling the anchor.set method. Up until now, we have been using the ticker method to update the properties of elements, but we are able to do the same thing with pointer events, which include touch and mouse events. So, say we want to scale the sprite by clicking on it. To do that, we need to call the on method on the sprite instance, which is similar to the add event listener method, so it takes an event and a callback function in which we set the logic we want to run each time the event is detected. Then we have to set the interactive property of the sprite to true. This is a crucial step because it activates the event's detection on the sprite. Let's test this out, and it works like intended. An accessibility thing we can do is to give a hint to the user that the image is clickable by changing the cursor icon to a finger pointer, like a link or a button. To do that, we need to set the button mode property of the sprite to true. On the other hand, we need to use the classic add event listener method for keyboard events. So in this case, we are checking if the pushed key is the right or left arrow, and based on the result, we are going to add or subtract 10 pixels from the X position of the sprite. Sometimes you want to wrap a group of two or more sprites in one single container, and the most common example of that is characters and their weapons. It is basically the same concept of layers groups in Photoshop. That said, to create a container, we need to make an instance of the Pixi container class. Now, instead of adding the sprite directly to the stage, we need to append it to the container we've just created. Let's create another sprite and add it to the same container. That done, now we need to use the addChild method to add the container to the stage. As we didn't change the positions of the images, they are on top of each other, therefore the size of the container is merely equal to the size of the biggest one of the two sprites. However, if we change the position of the second sprite, for example, the size of the container will change accordingly. We can also reposition containers like we do with shapes and sprites. An important thing to keep in mind is that the position of the sprites within a container are relative to the container, not to the entire stage. To better understand that, let's try to get the X position of the third sprite and see what we will get. And as you can see, the X value is equal to 0 instead of 200, which is the amount of translation we already applied to the container, and that's because the container itself has its own grid, which is followed by its children. That said, we are still able to get the global position of the sprites that live within the container using the getGlobalPosition method instead of X or Y, which again represent the local position of a sprite. There is the children property, which holds all the sprites that belong to a container. Furthermore, there are actually two types of containers, the one we've just seen and the particle container. A particle container works pretty much the same way as the regular container, however, it is way more performant, and that actually comes with some compromises because this type of container doesn't have all the features that a regular container has. Having said that, a particle container implements the basic object transformations like scale or rotation and some advanced functionalities like tint. However, other more advanced functionalities like filters, which we are going to see later, are not available. So, to create a particle container, we need to instantiate the Pixi particle container class, and within the constructor method we can set a few parameters and configurations. The first parameter is a number which represents the maximum amount of elements that the particle container should have. The second parameter is an object in which we can either add or omit some properties for the sake of performance. Of course, the less properties the particle container has, the faster it becomes. The first property is position. The default value of this property is true, which means that we can change the position of the elements that belong to this particle container. Rotation. The default value of this property is false, which means that we can't rotate elements that belong to this particle container unless we set it to true. Vertices. The default value of this property is false, which means that we can change the value of the scale or the anchor position of the children, for example, unless we set it to true. Same thing goes for tint and UVS, which is needed for sprites animation. More on that later on. To load images and other kind of assets into a Pixi.js app like a JSON file, for example, we need to use a loader. To do that, we can either create an instance of the Pixi.js loader class or just use a pre-made instance, which is exactly what I'm doing here. Now that we have the loader instance ready, to load an image we need to call the add method. The first argument here is the name of the property which will be containing the loaded asset, which is the image in this case. The second one is obviously the file path. Then we need to call the load method to start the loading process, because add is just a sort of a preparation before the actual loading of the file. The setup argument here is a function which holds the logic to run once the asset is loaded. That said, let's create this setup function, and by the way, the name is arbitrary, so you can name this function as you like. So as you see, setup takes two parameters. The first one is loader, which is basically the loader that will be used to call this function. The second parameter is an object, which will be filled with the loaded asset. Now, since we are going to load an image, we can create a sprite out of it. So resources again is an object containing the loaded assets. Char4texture is the property holding the loaded image. A loader can be used to load multiple assets. All we need to do is to call the add method with different arguments. And for a cleaner and more concise code, we can chain call all of these methods. Another way of loading multiple assets is to use add only once, but we need to pass an array containing each file path as an array element. That done, if we take a look at the page, you see that the sprite we added is gone, and we have an error message in the console, and that's because of the char4texture property, which no longer exists because we used a different way to call the add method. So since we can't name the loaded assets this way, the loader simply sets the path to each file as its key in the resources object. Now, if we take a look back, the sprite appears again. Loaders have a set of other methods also known as loader signals. These methods run some logic depending on the state of the loader. For example, onLoad is dispatched each time an asset is loaded. onError is dispatched when the loader fails to load an asset. onProgress is dispatched every time the loader fails or successfully loads a file. So, up until now we've been creating sprites by making a texture out of a single image, then pass it as an argument to an instance of the Pixi Sprite class, and then add it to the stage. This method actually works if you want to add a very limited number of images to the stage. However, in a game you'd have multiple characters, which means multiple images, thus multiple requests for the images, which results in a lot of loading time, not to mention how bad it is in terms of performance and memory usage. A better solution to that is to use a tileset instead of loading single images. But what is a tileset, you might be asking? A tileset, also known as a sprite sheet, is merely a big image that contains a set of sub-images. So instead of loading each image on its own, we can load one single image and then crop the part we need and create a texture, then a sprite out of it. To do that, we first need to load the image, obviously. Then we need to create a texture out of the image. Now what we want to do is to create a rectangle that has the size of the part that we want to crop from the texture, and then place it at the coordinates of that wanted part. Having said that, in this example, 176 and 160 refer to the coordinates of the third character at the second line. 76 and 86 refer to the width and height of the rectangle respectively. Now that we prepared the rectangle, we need to apply the crop, and to do that we need to set the rectangle as a value to the frame property of the texture. The rest is pretty much the same as what we have been doing to create and add a sprite to the stage. Let's try to create another sprite and see what will happen if we use the same code we've just used. As you can see, even though we changed the coordinates of the rectangle, we got both sprites pointing to the same character in the tileset. Well, that's because texture 1 and texture 2 are actually pointing to the same texture object. So to create a true copy of the texture, we need to make a new instance of the Pixi texture class. There is another way of creating sprites besides the two methods we've seen, which I think is the best when it comes to game development. This method consists of creating a sprite sheet coupled with a JSON file which contains the size and the position of the character or whatever part we want to take from the texture. This way we can skip the creation of the rectangle in the cropping process, which leads to a more concise and organized code. To better understand that, say we want to create a tile set from these 12 dragons. To do that, we need to create an image out of each dragon, which I have already done. Then we need to either install a generator or simply go to this website, clear this canvas, and then drag and drop the images. Then we need to download the generated PNG and JSON files. As you can see, a new sprite sheet is created coupled with a JSON file, which again contains the size and the position of every dragon on the tile set. Each one is assigned as an object that has the file name as identifier. That done, now let's create a sprite using these files. So the first step we need to do is to load the JSON file. The next step is to simply use the Pixi texture from method and set the name of the part we want to create the texture from as an argument, and the name here is basically the key set as identifier to the part of the tile set within the JSON file. The rest is pretty much the same as we've been doing. An important thing to keep in mind before we go to the next section is that sometimes you want to rename the PNG and JSON files, but that will result in a problem. Actually, let's try to do that and see what will happen. As you see, nothing appears now on the stage because Pixi is not able to recognize the PNG file. To fix that, we need to open the JSON file and go all the way down and update the value of the image property by setting it to the name we gave to the tileset. As you probably know, a video is basically composed of a sequence of frames or pictures. Actually, everything displayed on screens like games are also composed of a sequence of frames displayed per second. So back to the tile set, notice that we are having a variety of positions or movement captures of the same character, not a set of different characters. This is actually one of the reasons why sprite sheets exist, because they merely represent a collection of all of a character's movements. That said, to create an animated sprite out of this tile set, we need to do the following. The first thing we need to do is to load the sprite sheet. The next thing is to create an array of textures, each created from one of the dragons on the sprite sheet, so this array must contain 12 elements. That done, now we need to make a special type of sprite by creating an instance of the Pixi animated sprite class, then pass the array we've created as an argument to the constructor. Then we can do some positioning and add the sprite to the stage. Now, if we take a look, as you see, we got the dragon on the stage, but it is not animated. So to do that, we need to call the play method, which will start changing the texture of the sprite in order to make it look like it is moving. As you can see, the textures are changing fast, which makes the animation look so fast. So to fix that, we need to change the value of the animation speed property. And there we go, we have a flying dragon created out of the repetition of the 12 textures on the sprite sheet. Infinite 2D games backgrounds were like a mystery to me. The funny thing, it turns out to be not as complicated to create one as I thought it would be. If we try to analyze this game, you'll probably notice some repeating patterns, like the plant, the sand dunes, and the pyramids. Also the clouds, which seem to be coming in a random order, but they are actually repetitive. Having said that, let's add some clouds to the background here. So the first thing we need to do is to create a texture out of the image. Then we need to create another special type of sprite by instantiating the Pixi tiling sprite class. So once added, you see only a 100 by 100 pixels part of the image appearing, which is the default size if we don't specify explicitly a size. Therefore, to change these default values, we need to add another couple of arguments to the constructor method representing the width and height of the space that needs to be covered by the sprite. An important thing to keep in mind here is that since the size of the image is not enough to cover the entire sprite, a new copy of the same texture is created to cover the empty space. This is basically the same idea as background repeat in CSS. Now, to apply transformations on the tile sprite, we need to use some special properties. So if, for example, we want to reduce the scale of the clouds, we can't use the scale set method because that will shrink the entire space covered by the sprite. Instead, we want to reduce the scale of the texture and then fill the rest of the space with another one. So to do that, we simply need to use the tile scale set method. Now let's see the result. And there we go, we have smaller but more clouds. To animate the clouds, we need to change their position, but again, if we change the value of the X property of the sprite, the entire covering space will be moved. So instead, we need to move the texture within the sprite and make it in a way that the empty part is automatically filled with a new texture. To do that, we need to change the value of tile position X instead of X directly. Audio is a crucial component when it comes to games. Having said that, Pixi.js doesn't have built-in functionalities to work with sounds, so we need to install a module to take care of that. A great library I found is Howler.js, so let's install it. Open the terminal and type the following command: npm install Howler. That done, now we need to link it in the HTML code. The next step we need to do in order to add background music to the scene is to create an instance of the Howl class. Then we need to pass a configuration object to the constructor method that must contain an src property, which value is the path to the audio file we want to use. Then we just simply need to call the play method to start playing the music. We can apply a variety of filters to sprites on the stage. In this case, let's blur the dragon to add that blurry effect when the camera focuses on the background instead of the closer parts in the scene. To do that, we need to create an instance of the blur filter class. Then we need to add it to the filters property, which contains an array that holds the effects to apply to the sprite. The constructor method takes a handful of optional arguments, but the first is probably the one that you want to use most, which represents the strength of the effect. The default value is 8, so passing 15 here will add blurriness to the dragon sprite. We can change the strength value after the instantiation by updating the blur property of the blur filter object. There are a few built-in filters that we can apply, and also another set that you can download from the Pixi.js filter repository. A couple things I need to tell you before the end of this video. First, I want to congratulate you because if you understood and followed all the steps I have done, you can confidently say that you have a solid knowledge base of Pixi on which you can build on top of it to start creating high-quality interactive content on your websites, web applications, and lucrative 2D games on web browsers and mobile phones. The second thing is that there is a lot more advanced stuff to learn, like plugins, the creation of custom filters, and GLSL and shaders. I also highly suggest you to take a look at the examples on their official website because they will open your eyes on a wide range of possibilities that are offered by this amazing library, not to mention how helpful they are since they provide the code of each example in case you want to achieve similar results. Finally, I hope I did a good job at helping you to get a good grasp of the essential parts of Pixi.js. So if you think I did, make sure to hit the like button and subscribe, and I will see you in my next video.